To another section of this program. I'm Adika Solomon. Today
Today
we'll be
we'll be
dealing
dealing
with
with the
trigonometry
trigonometry
of
of some special angles.
trigonometry ratio of some
Trigonometry
special
of some
angles.
special
And it
angles.
talks about special angles and 0 degree and 30 degree and 60 degree and 45 degree and 180 degree and 90 degree and 360 degree. So in our video we focus on those special angles and with more examples. Please don't forget to subscribe to Adika Mathematical Solution on, on YouTube. Follow me on Facebook, Instagram for more updates. You can share my videos. Thank you so much. Thank you. My friends, um, today we'll be dealing with trigonometric ratios of special angles. Um, so there are some things I would like to let you know about special angles. When we are talking about special angles, we are talking about angle 0 degree, angle 90 degree, angle 30 degree, angle 60 degree, and 45 degree, 80, 270, and, and 360 degree. So, before we go deeply into this topic, there is one thing I'd like to let you know. What we say are quadrants, which you have a cycle, and this cycle here is angle at a point is equals to 360 degree, and here is divided into four quadrants. So in here now, what I like to let you know here is angle 90 degree. Here being angle 90 degree, I will tell you here is A. There is what we call cast. Cast here is A, C, S, T. And here now is we are telling you that here the A stand for or, here is for cosine, here is for cosine, here is for tangent, here is for tangent, here is for sine. So what this is explaining here is um the angle now is telling us that here is only all the angles under this 90 degree. From 0 to 90, the angles there, they are six, they are positive. Coming here is only sine that is positive. Here is only tangent that is positive, and here is only sine. Let me come again. If you look at this angle, here all angles here are positive. Here angles here is this cosine here is positive, that is cos is positive here. Here is the tangent, that is tan is positive, and here is sine. So the angles move here. Here it moves from 0 back to 360 degree. So from here we say 90 degree, 180, 270, and 360. 180 degree, 90 degree, 270 degree, and here 360 degree. So um as as you be moving further to solve this, there is some special hint I'll give you, which I'll say we start with angle 0 degree and angle 90 degree. So here we say sine 0 degree is equals to 0 cos 0 degree is equals to 1 tan 0 degree is equals to 0. You have to know this. when we are talking about angle 0 degree, that's here 0 degree. So when we are talking about 90 degree, angle 90 degree, angle 90 degree, here sine 90 degree, okay, of sine 90 degree, sine 90 degree, sine 90 degree, how will be equals to 1. Sine 90 degree is equals to 1 cos 90 degree is equals to 0 tan 90 degree is undefined. So now after this one, we are going to move to the angle 30 degree and 60 degree, which it's a very interesting part of this lesson. Let's draw this line or to divide this. Okay, so from here we are talking about angle 30 degree and 60 degree. Okay, so from here, um for us to find sine 30, cos 30, sine 60, cos 60, tan 30, tan 60, we are going to use this. We are going to use, don't mind the way I draw it, but this angle is called equilateral triangle. The all sides are equal. So when we have this, here is 2, here is 2, here is 2. All sides are the same. Here is 60 degree, here is 60 degree, and here is 60 degree. Or when you sum the two angles, the sum angle in a triangle is equals to um 180. So when you sum this, give you this 2, you give you 120 plus this is 180. Okay, so from here, this angle we are going to divide it into 2. So when you divide this angle here will be, this angle we divide here will be 30 degree, and here will be 30 degree. So you divide this 60 into 2, here will be 30 degree, here will be 30 degree, and the length here, this angle this side will be 1, this one is side, because from here to here is 2. So when you are dividing here to here will be 1, here to here will be 1. So the angle here now will be 90 degree, here will be 90 degree. Okay, so from here we know our size. That is, we have angle here. This is how our angle is looking like. And here is 60 degree. Here is 30 degree. Here is angle 90. Here is 2. Here is 1. And here is unknown. So this angle is the same thing. We are just removing part of it to work with. So for us to look for the side of this, let's call this our h, which is the, let's call it our height. For us to find this side, we apply what is known as Pythagoras. So let's say Oh, using Pythagoras, let's say, using Pythagoras, using Pythagoras theorem, and the Pythagoras theorem says the hypotenuse side square is equals to the opposite and the adjacent side. Let me not speak the grammar, but what the Pythagoras says, this length here, when the square of this length is equals to the sum of the square of these two lengths. So uh, we say 2 square, which is the hypotenuse, is equals to h square plus 1 square. Okay, so from here 2 square is equals to 4, which is equals to h square plus 1. 1 square is 1. So when you are collecting like terms, your h square will be equals to 4 minus 1. When you take this positive 1 to this side, it becomes negative 1. So here it will be 4 minus 1, and our h of square will be equals to 3. But we are looking for the height. We are looking for the h, not the h square. So when we remove the square, this side, we introduce the square root this side. So our h now becomes um square root of 3. So when we come to this side, um when we comes to this side, we say here is the square root of 3. Okay, so we'll be dealing with this diagram here. It's very important. We'll be dealing with the program, the diagram. So when it comes to this, we start looking for our angles. Okay, we start looking for our angles, and in our angles we now says um but before we go, I'd like to explain this to you again, what is known as SOHCAHTOA. SOHCAHTOA. What is known as SOHCAHTOA? SOHCAHTOA, the S here is for sign, and the SOHCAHTOA is telling us the O here is opposite. The H under this is the hypotenuse. Okay, and uh, the C here is telling us cosine, which is written as cos. Let's say, let's use the angle to be theta. Up, then it will be A is for adjacent and the H is for hypotenuse. Okay, again let's look for um tan theta will be equals to SOHCAHTOA here is a O, which is opposite, and our A is the adjacent. So that is the meaning of SOHCAHTOA. So we'll be applying SOHCAHTOA in this. So first of all, let's look at sine 30 degree. Sine 30 degree. So we look at the angles 30 degree first, and the sine 30 degree is equals to If you look at this angle here, if you look at this angle, look at 60 degree, look at 30 degree. So when we are dealing with this 30 degree, the opposite of this 30 degree is 1. The adjacent is root 3 and the hypotenuse is 2. Is that taking? So here our sine 30 degree is SOHCAHTOA, applying SOHCAHTOA opposite our hypotenuse. And our opposite here is 1, our hypotenuse is 2. So sine 30 degree is 1 or over 2. Okay? So let's move to sine cos 30 degree. So cos 30 degree here, we look at this SOHCAHTOA. Cos is adjacent of our hypotenuse. Okay? So from here, our adjacent is 1. Okay, our adjacent, we are dealing with the angle 30 degree. So our adjacent is root 3. The hypotenuse is 2. So here it will be root 3 all over 2. And now we look at tan 30 degree, which tan 30 degree here, if you look at this angle, tan says opposite of adjacent. And when you look at this, the opposite of 30 degree is 1 and the adjacent is root 3. So here it will be 1 over root 3. Okay, this is for angle 30. Is angle 30 degree. Okay, let's move to angle 60 degree. Angle 60 degree. So angle 60 degree here, it says sine 60 degree. So sine 60 degree, when you look at this angle here, now we are no longer dealing with 30 degree, but we are dealing with 60 degree. So the 60 degree here, the opposite is root 3, the adjacent is 1, and the hypotenuse is 2. So sine 60 degrees, sine says SOHCAHTOA, so that is opposite of a hypotenuse. Sine, opposite of a hypotenuse, and our opposite here is 3, so we say root 3, opposite of a hypotenuse, which is root 3 over 2. When we talk about cos 60 degree, now if you look at this, it says SOHCAHTOA, okay, the SOHCAHTOA that is adjacent of a hypotenuse, and our adjacent of a hypotenuse here, this is the adjacent and this is the hypotenuse, is 1 over 2. And we look at tan 60 degree, and our tan 60 degree here, if you look at here, it says SOHCAHTOA opposite TOA, SOHCAHTOA, which is TOA opposite of adjacent, this is the opposite, and this adjacent, which is root 3 over 1 is equals to root 3. Okay, so this all we have about the 60 and 30 degree. So we'll be looking at we'll be moving to angle from 40 degree. I hope you're enjoying the video. Please don't forget to subscribe to my YouTube channel, Adeka Mathematical Solution, for more updates. Follow, you can follow me on Facebook and Instagram. Okay. So now we'll be moving at angle 40 degree. So angle 40 degree, nice angle 45 degree. Here we have what is known as isosceles triangle. We use this isosceles triangle. I'm using freehand, but when you're using Mitaro, you know what I'm talking about. Isosceles triangle. In the isosceles triangle, the two sides are equal. So, in since the triangle, the two sides are equal. Here we have angle 45 degree, and here we have 45 degree, and here is 90 degree. And if you can remember, I told you uh, in in triangle, the sum of a triangle is equals to 180 degree. So when you sum this, 45 plus 45 is equal to 90. And this one here shows that it's angle 90 degree. So here the side is 1, here is 1. So we are looking for this size, which is called the hypotenuse, and let's label it to be x. Okay? So for us to look for this side, we apply, we still using Pythagoras theorem. Okay? Pythagoras theorem, which I mentioned before. Pythagoras theorem states that the square of the hypotenuse is equals to the square of two sides. So here, our x square will be equals to 1 square plus 1 square. Our x square is equals to this side square plus this one square. Okay? So our x square will be equals to 1 square is the same thing as 1. So here it will be 1 plus 1. So our x square is equals to 2. When you add 1 plus 1, it gives you 2. But we are not looking for x square, we are looking for x. So when you are looking for x, your x, now when you remove the square this side, then you introduce the square roots. So here it will be square root of 2. So here our x is equal to square root of 2. So I still using SOHCAHTOA here. SOHCAHTOA. As I earlier explained, no need of me explaining what a SOHCAHTOA means or the meaning of SOHCAHTOA, but I explained it earlier. So here you can say sine 45 degree equals to sine 45 is SOHCAHTOA opposite of a hypotenuse, and the opposite here is 1. The hypotenuse here is root 2, so it will be 1 over root 2. Okay, and then we have cos 45 degree. Cos 45 degree says when you have cosine is adjacent of a hypotenuse and adjacent is 1, the hypotenuse here is root 2. So it's the same thing as 1 over root 2. So we have tan, that is tan 45, tan 45 degree, and the tan say opposite or over adjacent. Opposite or over adjacent, and our opposite here is 1, the adjacent is 1. So it's 1 over 1, which is equals to 1. Okay, so now as we are through with this, we will be moving to another angle. Stay tuned for more explanation. So, but before we move to the next explanation, there is what I will like to explain further. This is not the final answer. Then the sine 45 degree here, there is what we call in short rationale. Then we rationalize this. When you have something like this root 2 and you want to rationalize, you multiply it by this root 2 all over root 2. So when you multiply this, 1 multiplied by root 2, it gives you root 2. And root 2 times root 2, in my other explanation when we deal with a square root, when I treated about square roots, how to multiply, the divide, and work on square roots. And I told you that when you multiply roots of the same value, is the same. So root 2 times root 2, it gives you 2. So sine 45 degree is equals to root 2 all over 2. Okay. So um cos 45 degree now is equals to, you still do the same thing, root 2 multiplied by this all over this, and you have, when you multiply, you still have root 2 all over 2. Okay, for tan we have tan 45 degree is 1. So now we are done. I will be looking at other angles. And the next angle that we'll be dealing with angle 180. One angle 180 degree. 180 degree. Okay. So here you will recall that in the second quadrant, the second quadrant, uh, um, which I treated with you. Okay. The second, when you recall, in the second quadrant, which is 180 here, second, if you take it like this, let's say this is the first quadrant. Okay. And if you take it, you know that your sine, have sine 180 degree minus theta is equals to sine theta. And here, without explaining and taking much of your time, we know that sine 180 degree is equals to 0, cos 180 degree is equals to negative 1, and tan 180 degree is equals to 0. So here we move to angle angle 270 degree. Angle 270 degree. Okay, so in angle 270 sine 270 is sine 270 degree is equals to negative 1, and cos 270 degree is equals to 0. 270 degree is equals to 0, and tan 270 degree is undefined. Okay, undefined. Okay, so we deal with 360. Angle 360, angle 360 degree. Okay, don't mind my space or some engine. It says sine 360. When you say sine 360 degree, it's 0. Sine 360 degree is 0. Cos 360 degree, 360 degree is equals to 1. Tan 360 degree is equals to 0. So please, you have to study all those things, keep them in your brain as you are going to use them. But before we move to the further explanation, I want to explain something to you in this quadrant. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. So when you see something like this, don't get yourself confused. So now we'll be looking at um, addition formulae. When you are to add maybe sine a plus b, what to do. Okay, so as we are dealing with addition formulae, we call it addition formulae. It's not addition formula because there are many. The plural of formula is formulae. So addition formulae, we say sine a plus b is equals to sine a cos b. Then I'm multiplying sine a by cos b plus cos a sine b. The matter of arrangement does not matter. You can say cos b sine a plus cos a sine b. Since addition is commutative. Okay, so here when we have sine a minus b is equals to sine a cos b minus cos a sine b. Okay, so the difference between this is just the sign here. Okay, then when we have cos a plus b, cos a plus b is given cos a plus b is given as cos a times cos b minus sine a times sine b. But when you have cos a minus b, it gives you cos a cos b plus sine a sine b. Don't be confused. When you have cos a plus b, the sign here will be negative. When you have cos a minus b, this sign here will be positive. So now we move straight to the examples to make you understand. But before we move to the example, let's deal with the tan. And tan A plus B is equals to tan A plus tan B all over 1 minus tan A tan B. Okay, here when we have a positive here, is 1 minus. Okay, you add here, but here it will be 1 minus tan A tan B. Okay, and here when we have tan A minus B, when we have a negative here, is equals to, here is negative, but here it's positive. So study this very well as we move straight to the example. Stay tuned as I give you many more examples. Okay, so in the example, if alpha and beta are acute angles such that sine alpha is equals to 3r over 5 and tan beta is equals to 5 over 12. Find without using tables sine alpha plus beta as A sine alpha plus beta, B cos alpha plus beta, C sine alpha minus beta, D cos alpha minus beta, E tan alpha plus beta, EF tan alpha minus beta. So as a solution, if you look at these questions, we have two triangles there. Okay, and the first one is talking about angle beta, while the other one is talking about angle alpha. So let's draw the diagram. I'm using freehand, so don't mind me. Okay, but in the here is angle 90 degree. Don't mind my here is 90 degree. Here is 90 degree. Okay, so like I was explaining earlier, this is angle alpha and these are angle beta. So I was explaining, I made mention of something SOHCAHTOA. In the SOHCAHTOA now we have a sine is 3r over 5. So SOHCAHTOA, SOHCAHTOA now will be telling us where we are going to label the triangles. So from here we have sine alpha, and sine alpha we have SOHCAHTOA opposite over hypotenuse, and the opposite here now will be 3 and the hypotenuse will be 5. So we are going to look for this. Let's call this x. Okay, so when you comes to this angle now beta, you say the tan theta is 5, the tan beta is 5 over 12, and you say SOHCAHTOA opposite, that means the 5 here is the opposite here is 5, toa, and here that is adjacent will be 12. So when you read the question and you understand the question, you have already known the answer. So here we are going to use this. We apply the Pythagoras theory to find this, and let's call this our y. And here our y square will be equals to 12 square plus 5 square. Okay, we are looking for this. So our y square will be 12 square is 144, and our 5 square, our 5 square is 25. So our y square now will be equals to when you add this, it gives you 5 plus 4, it will be 9, 2 plus this to be 69, and here will be 169. So our y now will be equals to the square root of 169. So when you find the square root of 169, if I'm not mistaken, the square root of 169, you will get a y here will be 13. Okay, you can check as well. Okay, it will be 13. So here now it will be 13. So when you find this one, you are looking for x. So here our 5 square will be equals to 3 square plus x square. Okay, so here we have 25. 5 square is 25. It equals to 9. 3 square is 9 plus x square. So when you find this, you discover that here our x square is equals to 25 minus this positive, we move this side, it change to minus 9, and our x square will be equals to 16. Our x will be equals to 16, and x will be equals to square root of 16 is 4. So here it will be equals to 4. Okay, and I hope you are following. Okay, so now we move to the solving. Okay, as we are moving ahead, we say the A part now says, oh, the A part says, uh, says sine alpha plus beta. Okay, so here our sine alpha plus beta, we say from the addition formulae, where we have sine alpha plus beta here, sine alpha plus beta, okay, is equals to sine A cos B plus cos A sine B. Okay, so here sine A here, here we are not using A, but it's alpha and beta. So here is equals to sine beta, sine alpha cos beta plus cos alpha sine beta. So when we look at our solving here, sine beta, sine alpha is given as it is given in the question here, is 3 over 5. So here it will be 3 over 5 times cos beta. When you look here, cos beta, SOHCAHTOA is adjacent of a hypotenuse, and our adjacent here is what? Is 12 over 13. So here it will be 12 over 13 plus, okay, I hope you are following, okay, plus cos alpha now, cos alpha now will be SOHCAHTOA adjacent of hypotenuse, that is 4/5 times sine beta. Okay, when you look at sine beta here, so that is opposite of a hypotenuse, that is 5/13. So when you multiply, okay, when you multiply this, you say 3 times 12, it gives you 36. Am I right? 3 times 2 is what? 6, and it will be 36. Okay? And 5 times 13, it will give you 5 times, this is 15, it's 13 times 5. 5 times there, it will be 15. You put 5, carry 1, and 5 times this is 5 plus that is 65. So it will be 36/65 plus 20. 4 times 5 is what? 20/65. So for us to find the LCM here, the common here is 65. So 65, since they are the same, you will add the numerator. So it will be 36 plus 20, which equals to 56/65. Okay, so we move to the B part, which says the B here. Question B says cos alpha plus beta. Okay, cos alpha plus beta here, and we look at the formula here. We have cos A plus B. Okay, so from here, cos alpha plus beta is equals to cos A cos B. Cos A cos B minus sine A sine B. Okay, but in our own we are using beta, so it will be equals to cos alpha cos beta minus sine alpha sine beta. Okay, so when we have this, we still move straight to this to this. Okay, the diagram, we are going to use the diagram to solve everything now. Okay, and when you look at the diagram, we have cos alpha is what? SOHCAHTOA adjacent of hypotenuse. So the cos here is adjacent, that is 4/5, will be 4/5, okay, times cos beta, using SOHCAHTOA cos beta is adjacent of a hypotenuse, that's 12/13. B. Here now, it will be 12/13. Then we are going to subtract, and when we are going to subtract this side, sine alpha, as it is given in the question, is 3/5 times sine beta. Okay, sine beta, SOHCAHTOA opposite over what? Hypotenuse. That is 5/13, which is 5/13. Okay, 5 over 13, when you multiply this, you have 65. Here, when you multiply 4 times 12, it gives you 4 times 2 is 8, plus this 4 times this is okay, 8. 4 times this is 48. So it will be 48 minus this times this 15 over 65. And when you find the LCM, it will be 65, and you subtract the powers. Say 48 minus 15. That's 48 minus 15. Okay, let's do it. 48 minus 15. And here when you say 8 minus this, it gives us what? 3, and this 3. So the answer will be 33 all over 6, 5. You can see how simple it is. I know you are enjoying it. So let's move to I will solve the part, then leave the rest to you to solve. It's just for you to substitute. And let's try the last part, which says let's do the F. And the F now says um tan alpha minus beta, and from the um from here, if you see tan A minus B, the formula there, so here is equals to tan alpha minus tan beta over 1 minus 1 plus tan alpha tan beta. Okay, so for that we will say tan alpha here is what? As it is tan alpha, you say SOHCAHTOA here is opposite of adjacent, that is 3 over 4. Here will be 3 over 4 minus tan beta is given in the question. 3 over 4 is given in the question to be 5 over 12. Okay, so here 1 plus tan alpha here is what? 3 over 4, and this is what? Here is 5 over 12. So when you multiply this, they say 4 times 12. 4 times 12 is first you say is equals to, you find the LCM here, you say 12. 12 is common here. 4 into 12, 3 times. 3 times this, it will be 9 minus 12 here. 1 times this. When it comes to this, you say 1 plus this times this, it give you 48. 4 times 12, it give you 48. And 3 times this, it give you 15. So when you are solving again, you say this 9 minus 5 is 4 over 12, divide by this. If you find the LCM, here is 1, you say 48. 48 into 1, 48 into 1, you get, and when you solve everything, you will arrive at a very nice answer, which it gives you. When you solve everything, it will give you, because there is no time by our side, but it will give you 16 over 63. If you solve, you arrive at this, because there's not much time here. But when you solve, you say 48 plus 15. Here now you can say 48 plus 15. Okay, so when you solve, it will comes to this.